Now let's talk about mesh analysis applied to the circuit with the super mesh. The question is to use mesh analysis to find currents I1 and I2 in the given circuit. And of course, the first step is to assign the mesh currents. We can see that there is 3 meshes, so we'll make the mesh currents as I1 for first mesh, I2 for the second mesh, and I3 for mesh number 3. And again, to make everything convenient, we'll assign the direction of the mesh current as clockwise. The question is to find mesh currents I1 and I2 in the given circuit. The question is to use mesh analysis to find currents I1 and I2 in the given circuit. And as always, we start in mesh analysis by assigning the mesh currents. We can see that there are 3 meshes in the circuit. Let's call them. The first mesh with the mesh current I1, the second mesh with the mesh current I2, and the mesh number 3 with the mesh current I3. To make everything convenient, we'll make mesh currents going clockwise, in the clockwise direction. But the interesting thing that between mesh 2 and 3, we have 5 amps current source, because the mesh analysis is the application of the Kirchhoff's voltage law. So we're interested in the adding up all the voltages in the loop, and we can see that we don't know exactly what's the voltage across 5 amps current source. So in this case, instead of using 3 meshes, the mesh 2 and 3 is assigned as the super mesh. So these 2 meshes, I2 and I3, will be treated together as the whole a super mesh. Now let's start writing mesh equations, and it will be easy to see what's the difference in writing the equation for super mesh. But before we start, let's write the equation for mesh 1. So for mesh 1 would be the equation. Again, looking into the direction of the mesh current, and we are going clockwise in this direction, start with 24 volts. We are moving from minus to plus, so we put negative 24. Then continue going through 10 ohms resistor plus 10 I1, mesh current I1. Then we have plus 40. And what we can see, in 40 ohms resistor there are 2 currents, I1 going, the current I1 going clockwise, and I2 anti-clockwise, so the opposite direction. So that's why we need to put I1 minus I2 equals 0. So this is the equation for mesh 1. Now we need to write the equation for super mesh. What's the difference? When we write equation for super mesh, so we need to write the equation for the whole super mesh, but we do not ignore the currents I2 and I3, so they should be in the same equation. How to do this? So let's start again with current with 20 ohm resistor. So from this point, what do we have at 20 ohms? 20 and the current I2. Then, following by this direction, we go into 30 ohm resistor. So we put plus 30. Now we put I3. Then moving to the next resistor is 20 ohms. So we put plus 20 I3, and the last resistor, it is 40, so plus 40, and again there are two currents, the current I2 going this way and the I1 going the opposite direction. So we put I2 minus I1 equals 0. Now let's simplify these two equations. So these two equations we received from equation for mesh 1 and equation for super mesh. But looking at these two equations, we still can't solve them. Why? Because we have three unknowns. First of all, we don't know the mesh current I1, we don't know the mesh current I2, and we also don't know the mesh current I3. So we have three unknowns and only one and two equations. So what we can do? We need to create one more equation from the current source of 5 amps. How to do this? Let's look into the upper node, this node, where the 5 amps coming in. So I just draw this node larger. So this is the node, the current of 5 amps coming into the node. And what other two currents actually belongs to this node? This is the current I2, this current. Look, it's also coming into the node. So we put the arrow in, and that will be current I2. And also there is the current I3 going out from the node. So it goes this way, current I3. Applying Kirchhoff's current law to this node, and we know that all currents coming into the node equals to the sum of all currents leaving the node, we can see that I2 plus 5 equals I3. So basically this is our equation number 3 we created. And what we can do? We can substitute I3 in equation number 2 by this number as I2 plus 5, and then we'll create two equations with only two unknowns. So this is our two equations, and we can see that by replacing mesh current I3 by I2 plus 5, we created two equations with two unknowns. So there are only I1 and I2 unknowns, and it is easily to solve these equations. So solving these equations, we can get the mesh currents I1, I2, and I3. So as the result of the solution, I1 is equal to negative 1.89 amps. I2 is negative 296, and the mesh current I3 equals to positive 2.041 amps. And once we found all three mesh currents, we pretty much can finish the question and answer what would be the currents I1 and I2 in the circuit. So again, looking into current I1, this is the current I1. There are two currents which contribute to the total value of the current I1. This is mesh current I1 and the mesh current I2. So looking into the direction of the current I1, we can see that the current I1 is equals to the current to the mesh current I1 minus mesh current I2. So which means that it will be mesh current I1 is negative 1.89 minus mesh current I2, so minus 2.96, and the answer for that is 1.07 amps, and The last question is to find current I2. So what would be the value of current I2? Again, looking into that current, we can see that the current I2 is the same as the mesh current I3. So it's the single current in the branch and it flows in with the same direction as the mesh current I3. So easy to say that I2 is the same as mesh current I3, and that equals to 2.0.41 amps. So now we found both currents I1 and I2, and we finished the question.